So when these binomial expansions are small, you might kind of start out by thinking, well, why not just multiply it out? It's easier. But when you get to a problem like this one, now you start to see why using something like Pascal's triangle might actually be helpful. So again, there's your squareds. This is for your cube. That's your fourth. I got to get to a sixth. So one, keep adding the two numbers above it. So there's my, if I were gonna do something to the fifth power, I'd go one more. Hopefully you're seeing how that Pascal triangle worked. You're always just adding the two numbers above it and kind of writing the answer in the gap right underneath it. So on this one, we're going to, boy, this is going to be a big honking problem when we're done. So we're starting, this is my sixth. So I'm starting with this one. And I'm just doing this 5x to the sixth power. So my exponents are always going to add up to the 6. Then, let's see if I change colors, maybe I can have you follow along a little closer. So now I'm going to do the 6. And then it's the 5x, we drop down by 1 degree, so the 5th, but then we have to pick up one of these, so the 4y to the first. So the 5 and the 1 exponent still add up to a 6. And then you just keep going like that. The next one, I've got the 15. And then it's the 5x to the 4th, but the 4y is squared, 4 and 2 adding up to the 6th. And we just keep plugging along. The 20, the 5x now down to the 3rd, and the 4y goes up to the 3rd. Simplify your answer. Holy smokes, this is absurd. And then we still going on. I've got the 15 here, the 5x to the 2nd, and the 4y to the 2nd. I mean, you might almost think, was it really necessary to do one this big? But until you do, oops, not 15. I circled the 6. Until you do one that is this big, you don't really appreciate it. I messed something up back here too, talking and writing. This should have went up to a 4. Because here my 4y is now going to go up to a 5. And then we got to get one more here, right? And we'll have it. So this one, we got your 5x to the 0 is just going to be gone. So this is just going to be my 4y to the 6th. So now what the problem is at this point is just finding out what all these big numbers are. Because like out here on this one, it's going to be the 5 to the 6th power, right? So you're going to, hopefully you got a calculator available for that, because I don't think you really want to do it by hand. 5 to the 6th power . (15,625). And the x to the 6th power. Now over here, we got to do the 6 times the 5 to the 5th power times the 4. Holy smokes. The 6 times 5 to the fifth power times the 4. 75,000. This is ridiculous. And then we got an x to the 5th and a y to the 1st. So I'll just not write it if there's a y to the 1st. Now on this one, we got to do the 15, 5 to the 4th, 4 to the 2nd, 15 times 5 to the 4th times 4 to the 2nd. 150,000. Are you kidding me? This would be the x to the 4th and the y to the 2nd. Now on the next one, we got the 20, 5 to the 3rd, 4 to the 3rd. Man, I have a real strong feeling that I'm going to have something wrong here. 20 times 5 to the 3rd times 4 to the 3rd. 160,000. They're getting bigger. And that's x cubed from here and y cubed from here. Now they should start dropping off again if I remember how this works. So the next one, we got a 15, a 5 to the 2nd, a 4 to the 4th. Whew. 15 times 5 to the 2nd times 4 15, 5 to the 2nd, 4 to the 4th. 96,000. X to the 2nd from here, y to the 4th from there. I gotta type all this in. Yeah, it says simplify your answer. There ain't no simplifying here. This is gross. All right, then the next one, 6 times 5 times 4 to the 5th. 6 times 5 times 4 to the 5th. 30,720, if I did that right. X to the 1st from here and a y to the 5th there. Plus, finally, just 4 to the 6th. 40,096. However, this still is easier than if you imagine taking 5x plus 4y times 5x plus 4y times 5x plus 4y or times 5x plus 4y. We got to do this 6 times. This would be extremely, and why this method that I'm showing you here is still better than doing this out by hand. Now, I'm not going to guarantee that I don't have a mistake, but if I do, I'll go back and check my work to find where it was using a calculator. But the correct answer here, if I did all this right, 15, this is a lot to type and not have a mistake. X to the 6th plus 75,000. X to the 5th, y to the 1st, plus 150. Can't see my work up here. I'm gonna erase that stuff up there so I can see what I'm typing. 150,000. X to the 4th, y to the 2nd. Plus 160,000. x to the third y to the third plus 96,000 x to the second y to the fourth. All these exponents are always supposed to add up to 6. It looks like so far that part's right. And then plus 3720 x y to the fifth plus 4096 y to the sixth. I will be absolutely astounded if there's not a mistake in there. All right, so I'm confident in what we have for an answer, other than multiplying out all my coefficients. So the 5 to the 6th power on the first one, $15,625. I'm confident that that one was right. The 6 times 5 to the 5th, $18,750. Whoa, that's not what I wrote. 6 right here. 6 times 5 to the 5th, I got 75,000. 6 times 5 to the 5th, I'm getting 18,750 on my calculator right now. 18,750. Let me check the next one while I'm here. The 15 times 5 to the 4th times 4 to the 2nd. 150,000. I don't think, is this my final check? Nope, let's just hit enter and see if that one mistake was it. Nope. All right, so more mistakes to find. All right, I checked. 15 times 5 to the 4th times 4 to the 2nd and got 150,000. Let's try 20 times 5 to the 3rd times 4 to the 3rd. 160,000. The rest of these seem reasonable because they go down. But let's see, 15 times 5 to the 2nd times 4 to the 4th, 96,000. 6 times 5 times 4 to the 5th, 30,720. Whoops, I didn't type it in right. And 4096. Did I type all the rest of them right? Let's see if that is it. The correct answer. What did we not have right? Oh, I left off. Wait a minute. Oh, they don't show it all. I gotta scroll over it. Well, I would contend my answer looks exactly like theirs, except I didn't use commas. Let's see, 15, 625, x to the 6th. Oh, this 70. All right, I did have that at one point, and then I changed it. All right, so anyway, I'm going to stop there and just say, okay, you understand the process. I did not get it correct. I will fully admit that, but I'm not going to take any more of your time on that problem. So, but that's how, that's the process. It's a little tricky. I'll give you a hint. If you watch this far into the video, I would use something to solve this problem myself. That's called www.wolframalpha.com. Have not shared that anywhere else up to this time, but that is what I would do myself. It's a math online site that would actually do all this work for you. wolframalpha.com. All right. Good luck. Hopefully you did better than I did. All right. We'll see you.